Is it audible? Good morning.
Good morning, sir.
Yeah, good morning. Good morning. So, up to last class, we have seen about the data link layer. That is, layer 2. So, in layer 2, we have seen only that half part because, in the previous things, we have seen that data link layer, it contains two parts. One is nothing but MAC, next one is logical link control, LLC layer. So, that LLC layer, it is responsible for error correction, error direction, flow control, error control. That MAC layer, it is responsible for assigning physical address. We have seen only that half part of data link layer, that is layer 2. Now we have moved to layer 3. The reason is for a lab purpose, because for the inner laboratories, the next exercise it is an IP address. So for that, covering this network layer, it plays a vital role. So that is one of the reasons we have moved to the module 5. That is nothing but the network layer. So next, we will few classes we will see what is internet networking, what is internet protocol, different types of protocol, how we are assigning IP address, because even assigning IP address plays a vital role. Because as a network engineer, suppose if you want to configure any the LAN, so you have to assign the IP address for each and every node. How we are able to assign the IP address, all these things we will see in this module. So layer 3 network layer, in that internet protocol plays the vital role. So in this section we will discuss what is internet networking, connecting networks together to make internet network or an internet. If you see here, this same diagram we have seen in the the previous module. So that even the data link layer, it will support hop to hop delivery. See here, the respective data link layer will support for a hop to hop delivery. So suppose I want to transmit from A to D. I want to transmit the information from A to D. So which is available with the different LAN with the long distance. So how many the link is required for me? How many link is required for me? So this particular node is connected to this switch, through this LAN. So to connect from here to here, I need one link, because this is one hop. So from here, this is another hop. This is another hop. So hop to hop delivery. So from here to here, one connection is here. From here to here, interconnect, one connection is here. From here to here, I need one connect. But that means, from A to this router or switch. From switch to this switch. From here to, I need the three different links is here. So now let us assume we want to transmit with the connect with the far away node. So that times, sometimes many hop will coming in between that, from one server to another server, from next server, because here we are not going for any the common that IP address for a particular node, because data link layer it will work purely based on the physical address. So for the physical address, that it will we cannot able to identify directly physical address from source to destination. It will check one by one the respective the switches whether the physical address is connected here or not. So it requires for this example it requires three links. Suppose if you want to transmit the very long distance, maybe I need a more number of link to interconnect between source and destination. That is the drawback of establishing the network using at the data link layer level. So to avoid that, we are going to create internetwork at the network layer level. We are going to create internetwork at the network layer level. So network layer, it identifies purely based on that IP address. So for each and every systems, every node, it have a different IP address. That is reasons, if in the systems in our lab also, if you are assigning same IP address, automatically IP conflict will be occur. IP, because IP address is having the different for each and every node. Suppose if I am connecting in the network, that means if I am connecting the different network using network layer, then automatically only one link is sufficient. That is nothing but host to host. From this host to this host. Because automatically that IP address, it is the respective or the individual address for each and every node. So automatically, it will using the single link, we cannot able to, it is not required to cut the link because that IP address everywhere if we go automatically depending upon that IP address assignment to any the switch will directly forward to the respective the destination. So if you are establishing any network, inter-network, at the network layer, so only one link is sufficient to interconnect. But in the data link layer, we need the more link to interconnect between one node to another node, one node to another. That is the reasons always that network layer and the internet protocol, the set of standard procedure which is used to establish internet network, it is called an internet protocol. Yes, set of standard procedure which is used to establish the internet network at the network layer, it is called as the internet protocol. So if you see that the network layer at the source, at the router, and as well as at the destination. At the source, what will happen? So the data from that higher the link will reach here. The data from higher link will reach here at the source side. So it will the process the data. Meanwhile, depending upon the respective the source address, the destination address, it update the routing table. It update the routing table. Then it add the IP packet with the routing informations because in a network layer, it converts that information into the packets. So it assigns the IP, the packets, then as well as the routing informations. It will pass us to data link layer. Then through data link layer, then through physical layer, it will be transmitted to the destination. In the destination receiving side, the same thing. It will go from physical layer to data link layer to network layer. So while it receiving the network layer, depending upon the routing information only, it identifies the respective destinations. Once it identifies the respective destinations, automatically that routing informations will be discarded here at the entry of network layer itself. The routing information will be discarded. Then along with that IP packet, then informations it passes to processing. So here that IP packet, that packet number will be removed while processing the information. Then it will transmit that the informations data to the higher layer. If you see here in the source side, depending upon the destination address, IP address, so it will update the routing table. Then it will add the routing information along with the IP packets. So depending upon the routing informations, it will identify the destinations. While receiving destinations, depending upon routing informations, it identifies destination. Then automatically, while entering into the network layer itself, the routing information will be discarded. Then while processing that IP packet, that is that the packet number, the packet information, all will be discarded while processing. Then remaining information will be passed to the higher level. So this is nothing but the function of network layer at the source as well as the destination. At the router, because the router will interconnect to different different network. In the router, what will happen? So from the data link layer, again the same thing. because that IP address, depending upon the IP address, it identifies the respective router. While entering that, it will discard the respective routing information. Then it will enter into the network layer of the router. Then it will process. While processing, that that IP packet will be discarded. Then depending upon the destinations, again it update the routing table at the router. It will affix routing informations along with the IP packets. Then it will pass to data link layer. Then it will go to the destination. So in a router, it is a combination of the destination to source. It is nothing but the combination of destination to source. It will do the operation of the two, because here if you see here, this is the router, this S1 S3. Here it does the operation of the receiving section. This is the receiving section. This is the transmitting section. So it does the operation of receiving section plus the transmitting section. So it receives, then it process, again it add routing information, then it will forward to the next one. So in a router, it contains both the functions. So the communications at the network layer in the internet, it is a connectionless, because at the internet layer, at the network layer, there is no physical connection. Only the physical connections will be established at the physical layer. It assigns IP address virtually at the network layer. To establish the connections is used to establish the connection from host to host. So there is no the physical connection between these two. It is a virtual connection. So the different that that IP the version is there, that Internet Protocol version 4. It is mostly used for assigning IP address. IPv5 it is used for assigning IP address for special purpose like military, like that. So these are the different versions. So IPv4, then IPv5, IPv6. So IPv4 it is mostly used to assign the IP address in the locally. So IP version 5 it is used for the special purpose like the military or any other special purpose. IPv6, due to the shortage of address in the IPv4, because that here the number of address is restricted. To compensate that, IPv6 now it came into the picture. IPv6 it assigned the respective IP address the globally. So as per our syllabus, we will see about IPv4 plus IPv6. So normally in our lab, we are assigning all that IP address, that is nothing but IP the version 4, Internet Protocol version 4. If you see the frame format of IPv4, so always it contains header plus information, header plus data. So header will vary from 20 to 60 bytes. Minimum it required 20 bytes. Minimum the length of the header, it is nothing but 20 bytes. So 20 into 8. So 160. The minimum it is nothing but the 160 bits. So it will vary from 20 to 60 bytes. So overall IPv4 format will vary from 20 to 65,536 bytes. So suppose for example, if the header length is the 20 bytes, so remaining 65,516 will be allocated for the data. Again, it is a variable depending upon the data length, depending upon the header length, it will vary. So if you see that in detail about the header, what are all the different field is available in the header. The first one, it is a version. So whether it is an IPv4, IPv5 or IPv6, it will represent the respective version. So the next is nothing but the header length. What is the length of the header? Because once we are identifying the version, then we have to know what is the length of the header, whether it is that 20 bytes or 30 bytes or 40 or 50 or 60. So what is the length of the header that we have to represent? Because without representing length of the header, if you are simply adding header with the data, then automatically the destination and the source, the router, they cannot be able to identify which information, which bytes is belonging to the header, which bytes is belonging to the data. To avoid that unnecessary confusions, here we are representing the length of the header also. The next is nothing but service. For example, sometimes some information, it may be that IP address information, it may be it required very urgent. So using this service, we can be able to create additional delay. We can be able to reduce delay for and faster transmission. All these things will be taken care by the service of that 8 bits. So this total length, it represents combination of all that that burst and header length, all these things, it represent the respective the total length. Then identification and the flag as well as the fragmentations. So all these things will be used to fragment the information. What is meant by fragmentation? Suppose if the length of header, it is too huge. Similarly, if length of the data is greater than this 65536, so we can be able to divide these into the different data fragmentations. So the fragmentation, it is nothing but if length of the header or data is higher than this IPv4, we are going to break the data into the small segment. That process is called as the fragmentation. So this identification, flag, fragmentations, all these things will be used to divide the length the data into the small data. Then it will identify using the respective identification number, whether it is in first segmentation or second or third. Then the flag is used to represent the boundaries of the respective segmentation. So next 8-bit, which is used to represent the time to live. So the data, how long it should be available in a IPv4 router, because we should fix some deadline. Suppose if without identifying, suppose if destination address is false, so the data plus header, the header will again float into the respective the router. It unless for an additional IP packets. So to avoid that, we are fixing some timeline to keep the respective the IP packets in the router link. If it exceeds the respective time, automatically that IP packet will be discarded. That means so that the respective destination IP address, it is under the fault conditions. It cannot be able to deliver the respective the IP packet. So automatically after that time, so the IP packet will be discarded. So that the time to live in a the particular IP packet in a router link, it is decided by the time to live 8. Then next is nothing but the protocol. So this protocol will use to represent which type of protocol we are going to establish for a transmission. Then next is header checksum, because even network layer, data layer, all these things will ensure error flow, as that is error control, flow control, to avoid unnecessary error in the transmissions. That is internet protocol network layer also will add some additional bit as a checksum. The checksum, I think we studied in the previous module, that is parity checksum, the parity check, then checksum. All these things we studied in the previous module. So here also we are adding the checksum to monitor the error flow in the network layer, So next 32 bits, which is used to represent the source IP address. The next 32, which is used to represent destination IP address. If you see that in a header, so this IP address, whether it is a source or destinations, it is nothing but 32 bits. So using the 32 bit, using this 4 bytes only, we are going to assign the IP address. Remaining are, it is only used to, it is indirectly, it is nothing but the control. It is nothing but the control bits. So only these 32 bits which is used to represent the respective, the source IP address or the destination IP address. So this option, if the source IP address or destination IP address or all these things, it exceeds the 20 bytes. Additionally, we are adding options to increase the header size up to the 60 bytes, So this is about the IPv4 header programmer. So the first 4, it is used to represent the version. The next 4 bits, it is used to represent the length of the indirect header. So the next is used to represent the types of service. Then the next field, it is nothing but the total length of IP datagram. Then next, it is nothing but identifications, IP flags, and the fragment offer. It is used for fragmentations and reassembly at the receiver side. Then time to live, it is 8-bit, which is used to decide how long the respective datagram will be there in the respective the router. So if it exceeds, automatically the datagram will be erased or will be discarded. The next is protocol, which is used to represent which type of protocol we are using, whether we are using TCP or UDP protocol in a higher level layer. So next in header checksum, it is a 16-bit. It is used to monitor error flow. Then 32-bit source address, 32-bit destination address. That IP option, if it exceeds the length, automatically we are adding additional thing to expand the header from 22 up to the 60 bytes. So the various service types, because I told that the service type, because all other things are, it is clear to us, service types. So it contains the 4 service types. One is nothing but minimizing delay, maximizing throughput, maximizing reliability, minimizing the cost. If this is one, automatically we can understand that IP datagram, it isn't very urgent. We should give a higher priority. If it is one, we should give a higher priority for the particular datagram, IP packets. So the exact word for IP packets, it is nothing but a datagram. So if it is one, so we will do higher priorities to pass the datagram to the destination to minimize rate to increase the speed. Then similarly to if next bit is it is in a one, then we have to maximize the throughput for a particular thing. We have to reduce the traffic for a particular the datagram. Then if it is one, we have to maximize the reliability. Then if it is next C is one, we have to minimize the cost. Even though if the traffic is high, we have to find the optimal path. Even though if delay is also high, suppose it take longer time also to reach the destinations, but we should select the shortest path to reduce the cost. So these are all the various types supported by the IPv4. So the precedent subfield was the part of version 4. It is never used. So different types. Minimize cost means it is 0001. So maximize reliability. So all these things, it is that 4. TTRC. Suppose minimize delay. So it is 1000. So minimize delay. If you see here, it is in 100. This is T. This is T. This is R. This is T. If it is 1000, that means minimize delay. That means D is 1, remaining are 0. So these are all the different types of service bits which is used to represent the various services. This is default service for the various protocol. And then that value list of the protocol port points. So if that value is 6, then it is TCP. If it is 17, it is an UDP. All these things are, it is a standard, the one fixed to one. Depending upon this value, it will identify the respective the protocol for a transmission. So the total length of the field defines the total length of the datagram, including the header. So the total length that we have seen, the total length field, it defines the length of the datagram, including header. That is the header plus the data. What is the length? It is nothing but refers to the total length of length field in the IPv4 header format. The fragmentations, they told, suppose if the length of bytes is very high, it exceeds our IPv4 that required data, then it will be divided into. So far, let us assume the length of the respective datagram IPv4 is, let us assume it is 1400 bytes. So, but the input length is, it is an 4000 bytes. So we cannot be able to transmit 4000 bytes simultaneously using IPv4 datagram. So we are fragmenting, breaking that 4000 into 1400 each. So 0 to 1399. So 1400 to 2799, 2800 to 3999. So we are dividing entire that packet into the separate datagrams. Then we are adding the respective the identifications as well as the flag at the boundaries. Then we are going to transmit the datagram. Then at the receiver side, again, depending upon the identifications, whether it is a first datagram or second datagram, because the identifications indicate the datagram number. In the receiving side, it receives, while receiving, it checks the identification number. Depending upon identification number, it order the sequence. Then it remove the flags in the fragmentations. Then it will reassemble at the receiving side to get an actual information, actual data. So this is nothing but the fragmentation. So identification field, flag field, fragmentation field, which is used to fragment the length data into smaller data, then it reassemble in the receiving side. So this is about the respective the IPv4 framework. So this class we have seen about what is the need for network layer, what is the need for internet protocol, because the network up to data link layer, it will establish connection between the hop to hop. From host to host, we establish, suppose we want to establish using single link, we want to go for assigning IP address in a network layer. That is the reason we are going for internet network, that is IP protocol, internet protocol. Then we have seen about different types of the protocol, IP version 456. 4 is it is used for assigning IP address for general purpose. 5 is for special purpose, like assigning IP address for military service or any emergency service, army services. Because that should be the separate the network that should not link with the general purpose, the society or public network. Then IPv6, due to the shortage of the assigning IP address in IPv version 4, IPv6 came into picture. IPv6, it assigns IP address that globally. Then we have seen about the header format for IPv4. It's combination of data, header plus data, IP frame format. Then we have seen about that various the header format, that is version, the length of that, the types of services, the fragmentations, all these things we have seen. So that's all about these things. So next class we will see about how we can be able to assign the IP address for a node using IP4 versions. We will see in the next.